We are now ready to start the webinar. Hello and welcome to the Next in Chess's 2019 webinar series, Pros and Cons of Different Construction Procurement. I'm Robert Barris, Manager of Environmental Stewardship at the Nova Scotia Health Authority based out of Bridgewater, Nova Scotia, and I will be the moderator for this seminar. This session will be recorded and all participants will be muted for the start of the presentation. If you have a question, please use the chat box on the bottom left corner of the screen. The presenter will answer questions at the end of the seminar unless they feel it will add value to answer during the presentation. If you wish to verbally ask a question, you can unmute by either right-clicking your mouse on your phone number in the audio box to the middle left or press *7 on your phone. I'm pleased to be able to introduce today's speakers, Gazelle Abraham and John Marshman. Gazelle holds a bachelor degree in architecture, a Master of Science in Renewable Energy and Architecture, and a doctoral degree in Resource Management and Environmental Studies at the University of British Columbia. Her doctoral research has been focused on adoption of integrated project delivery in the AEC industry. Gazelle's research on IPD has been conducted in close collaboration with industry professionals across the United States and Canada and has been supported by the Natural Sciences and Engineering Research Council of Canada and the U.S. National Science Foundation. Her research findings on IPD have been published in peer-reviewed journals and have been presented in numerous conferences. Gazelle is currently a sustainability consultant for high-performance buildings in Lower Mainland Facility Management Department of the Health Organizations in the Lower Mainland in British Columbia. John Marshman is the Executive Director of Facility Operations at William Ulcer HS, where he oversees engineering operations, environmental services, energy, parking, food service, waste management, materials management, and security for 3 healthcare facilities while supporting the planning and execution of Ulster's redevelopment agenda. After studies in engineering and music, John pursued parallel careers in consulting engineering and as a performing cellist. Drawn by the complexities of hospital systems, John spent the bulk of his consulting work in the design and project management of hospital construction and renovation projects. In 2012, John joined the Brant Community Healthcare System, where he served as Director of Facilities Planning and Redevelopment before moving to William Ulcer. Giselle and John, over to you.
Thank you, Robert. Thanks for the introduction. Hello, everybody. My name is Gazelle, and together with John, we will talk to you about different procurement models that are being used in the architecture, engineering, and construction industry of North America. I will start the presentation, and then I will hand it over to John. Here is the outline for our presentation. We start by talking about high-performance buildings. What are these types of buildings and how are they being defined? And then we will talk about the issue of performance gap. And then we will speak about different project delivery methods and focus the rest of the presentation on two models, P3 model and integrated project delivery, IPD model, and then we wrap up by identifying some of the opportunities and challenges of implementing integrated models such as IPD. Over the past century, we have learned that after roads, buildings are the most enduring and impactful artifacts. With advancements in science and technology, buildings became more complex and various specializations in design and construction services were developed. We have also understood that impacts of unchecked human activities are unsustainable. The mounting concerns about resource stewardship and environmental quality have continued to reshape expectations about buildings and their performance. If initially we were mainly thinking about the cost and schedule and aesthetic appearance of a building, then we started thinking about ambient temperature, air exchange, lighting, life cycle impacts of building materials, energy and water use, ambient noise, and so on. What are high-performance buildings? A couple of decades ago, the notion of high-performance buildings were introduced as a response to such concerns. There are many definitions of high-performance buildings. One common definition is that there are facilities that are designed in a resource-efficient manner and aim to minimize their adverse impacts on the environment and community while enhancing occupants' health and well-being. High-performance buildings are those that are buildable, operable, usable, and sustainable. However, successful delivery of high-performance buildings has been a challenge for a long time. Projects in the architecture, engineering, and construction industry frequently perform poorly against a variety of success measures such as cost, schedule, and quality. Performance gap is a term that is often used to describe the discrepancy between the anticipated and actual or measured performance of building projects. Performance gap leads to unsatisfied clients, additional costs, waste of resources, among other challenges. A review of the literature indicates that performance gaps have been observed in a variety of metrics that could be used to define the performance of a building. I'm going to show you a few examples. Turner and Flanco studied the energy performance of 121 LEED certified buildings and found 25% performance gap in energy use intensity of more than half of those buildings. A study conducted by Bartlett et al. Shows between 4% to 138% performance gap in water use intensity of the buildings they studied. And a study by FMI Corporation shows that building projects, 30% of building projects do not meet schedule or budget. A review of the literature indicates a variety of reasons for performance gaps. These reasons can come from different stages of the life cycle of a project, from planning and design through to operation and occupancy. And also, it is important to highlight that in general, the architecture, engineering, and construction industry is very slow in innovation adoption and is characterized as an inefficient adversarial environment. The aggregate measure of this inefficiency is captured by labor productivity through time. For example, between 1964 and 2012, labor productivity of the U.S. construction industry fell 19%, while all other non-farm industries improved by over 153%. So why is that? Why are we facing this issue of performance gap? The findings of various studies focused on project performance evaluation suggest that a root cause of performance gap is the fragmentation in the industry, segregation of design, construction, and operation, sequential approach to project delivery, and uncoordinated behavior. The fragmented environment of the AEC industry is characterized by three key dimensions. There is a vertical dimension, vertical fragmentation, that occurs between different phases of the project's life cycle, design, construction, and operation. There is a horizontal fragmentation that occurs between different disciplines and specialized trades, mechanical, electrical, and architectural. And we also have a longitudinal fragmentation that occurs between projects because project teams often disperse at the end of projects. This is not a new story. The fragmented structure of the AEC industry has been officially recognized as a root cause of many of the problems faced in this sector since more than 20 years ago. Studies show that the reason that we have not been able to address the fragmentation in the industry is rooted in how we organize and execute work and how we structure projects. In this industry, we often work in our own silos, taking responsibility for only what falls in our own area of work and expertise. The method used for procurement and delivery of a project have been found to play an important role in shaping project organization, nature of the relationships between team members, legal and commercial terms, rate of innovation adoption, and eventual project performance and end results. Here are some of the project delivery models that we are all familiar with: design, bid, build, construction management, design, build, and P3 and integrated project delivery. I briefly introduce or describe the first three, and then we will focus the rest of the conversation, the presentation, on P3 and IPD model. For design, bid, build, we all know that owner engages the architect to provide design services and prepare construction documents which are issued for competitive bids. General contractors submit bids for the project, and the construction contract is typically awarded to the lowest bidder. The architect administers the construction contract. The other common delivery model is the construction management, in which the owner engages the architect to provide design services and prepare construction documents. The construction manager works for the owner as a consultant, providing services that normally include design input on constructability, cost estimating, scheduling, bidding, coordinating of contract negotiations and awards, timing and purchase of critical materials, cost controls, and coordination of construction activities. Depending on type of the contract used, the owner may or may not engage the trades directly, the trade contractors directly. The other model that we are familiar with is the design build, which is a method of project delivery in which the owner contracts directly with a single entity that is responsible for both design and construction services for a construction project. As I mentioned, we want to focus the rest of this presentation on P3 model and IPD. Now I will hand it over to John, who will talk to us about his experience with P3 model, particularly in healthcare projects. Hand it to you, John.
Thanks very much, Ghazal. I assume I can be heard on the line clearly. So I think I've been introduced, but I wanted to start by giving you guys a little bit of context to William Osler Health System and the organization that I'm coming from. So we're a three-site healthcare system with sort of three hospital sites, two who are highly acute, and then the Peel Memorial Center, which I'll focus the bulk of our conversation on, which is an ambulatory facility. Brampton Civic, each of these sites has a little bit of the P3 DBFM model to it. Brampton, somewhat historic, opened in 2007, was the first public-private partnership hospital built in Ontario, and maybe the first in Canada, although Abbotsford might have been a little bit before it. About 1.3 million square feet, 608 beds, and as I said, the first P3. Etobicoke, the original building in Etobicoke opened in 1972. It was about 450,000 square feet and 282 beds. We added a new patient tower, which opened actually just recently in June of this year. It was completed in 2018, and it has the new patient tower was actually procured through a design, build, finance, and maintain contract attached to an existing facility which was managed in-house. And then the Peel Memorial Facility, which opened in 2016, it's a full-service ambulatory hospital, so there's no sleeping patients. And again, it's a DBFM AFP 30-year maintenance and life cycle contract. Peel Memorial is, it's really an integral part of our strategy with respect to the way that we're delivering care across our local health integration network, or what was our local health integration network. Our focus is really on at Peel site is on maintaining their health through increasing access to specialized ambulatory stuff. Just a quick look at some of the volumes that we do at Osler. Sorry, I'm having a little bit of trouble with the clicker here. We're obviously a rather busy health system with 300,000 visits in our EDs and UCC. Brampton Civic, I think, is the busiest ED in the country, or it sort of goes back and forth, but certainly throughput is one of our biggest focuses. Almost 500,000 outpatient visits, 65,000 surgeries, about 8,000 babies born. So we keep ourselves fairly busy. What I want to talk about today is really outlining the P3 DBF model and how we leverage the model to build the Peel Memorial facility. And I should note that it's one of the most energy efficient healthcare facilities in the country. And then I want to pull the pants down on the project a little bit and talk about some of the things that didn't work so well and some of the lessons we learned along the way and the challenges that potentially derive back to the model. So I'll focus on Infrastructure Ontario's design, build, finance, and maintain permutation of the P3 model. There are other permutations, including design, build, finance, the DBF model, just the pure build finance, or BF, and there's even a couple examples of a build, finance, and maintain where the owner retains the design, but the consortium handles the building, financing, and maintenance. Each of them have their own idiosyncrasies, but the tenets are generally common to the permutations of the model. So, framing the context that gave rise to this model, we obviously have an ever-growing need for healthcare everywhere on the planet, and thus an ever-growing need for healthcare infrastructure to support the services. Paired with this, governments constantly struggle to ensure that maintenance funding is allocated to healthcare facilities, leading to a substantive deferred maintenance burden that is frankly untenable. I think Canada's is somewhere in the $20 billion in healthcare alone, and when we look at I was reading the North American healthcare or the North American public infrastructure deficit is closing $2 trillion, with an extra 160 just to meet the needs through 2021. What the P3 model does, it's really a long-term performance-based approach to infrastructure procurement. The private sector assumes the lion's share of the risks, including the financing and construction of the project, as well as ensuring the effective performance of the infrastructure from design and planning through long-term maintenance. These costs are all stipulated up on the front end, providing cost certainty for long-range planning. No capital is distributed prior to substantial completion, which really incentivizes a compressed schedule, which is really one of the key deliverables of this model is that you can really get something built very quickly. Most significantly, the capital costs are spread over the lifespan of the asset, which obviously has accounting advantages for the public sector. P3 has enabled tens of millions of square feet of healthcare facilities to be built in Ontario over the last decade. So if we compare the P3 procurement process to a typical design, bid, build, and I know Ghazal has already talked a little bit to this, what we're really talking about is the what versus the how, and ensuring that they fall to the appropriate expert. As an owner, my expertise typically lies closer to the what. In a traditional design, bid, build process, so if we're looking, sorry, this slide was actually supposed to have animations, but I'll animate it with my little red dot here. So we in the typical design, bid, build process, We take a program, we develop a program where we take a program to market to hire a design consultant. That design consultant translates the what into the how, and then we RFP the how. We then go take that out to market, and the building is constructed, and then of course that's handed back through FM operations. And if you look at the red tiles on this slide, really identify the risks that are retained by the owner. When we look at the DBFM model at the top of the slide, we really develop an output specification and take that out to market. There are some additional steps in there, and then really the entire risk on design, construction, and FM operations is transferred over in one package, which allows for obviously a much quicker process and a much more substantive risk transfer between what we're responsible for and what we transfer onto the private sector. So if we look at this slide, it's really a simplified version of the team structure based on Infrastructure Ontario's AFP contract for a typical DBFM. On the consortium side, you have your design consultants, the construction team, the FM service provider and lenders working all in tandem through the special purpose vehicle that we call the project company. The owner is supported by the Ministry of Health, who is accountable for the delivery of the healthcare, and of course Infrastructure Ontario, who function as the procurement agent to ensure the process is adhered to. The structure enables the collaboration amongst the experts to optimize the facility to meet the output specification. The fundamental strength of the model, again, being the risk transfer. Expert and risk is really aligned, so the owner's accountable for the what, and the consortium is really accountable for the how. Another strength born of the collaboration is really the innovation potential that derives from the designer, contractor, and FM operator ostensibly sharing the same goal. The model brings a kind of a financial rigor which comes with private capital, the discipline that comes with private capital and the oversight and segmenting off of that capital that's not really feasible in practice in the public sector. The model, obviously, as we talked about before, optimizes the schedule by bundling the procurement of several vendors into a single procurement versus the cumbersome sequence outlined in the previous slide, as well as significantly incentivizing the substantial completion timeline and compressing that schedule. The model tends to generate highly efficient buildings through the incorporation of really rigorous energy targets, and again, that collaboration between the designer, the constructor, and the operator. So I want to use Peel Memorial as an example to talk about both some of the successes and some of the challenges that this model generated. Obviously, some fairly impressive results. We got ourselves below an energy performance target of 1.25 gigajoules per meter squared through the use of heat recovery chillers, a dedicated outdoor air handling system, condensing or dedicated outdoor air supply, condensing boilers, variable speed fans and pumps, the first geothermal system, which was integrated into a healthcare facility, certainly in Ontario, a really complicated automation system from Honeywell. And we managed to, even though the project was really mandated to meet LEED Silver, we were able to achieve, through innovation from the project company and innovation on our side, a LEED Gold certification. And again, it's a DBFM which is operated for 30 years. With to the victor go the spoils. Obviously when we opened it, I became a Mr. Popular. This is a picture of me next to my CEO, among others, receiving over a $500,000 check from the local utility company. And everything was grand at the beginning. moving forward, and I apologize, this slide kind of gives away the story. It was supposed to be an animation, but as I was idly wondering what to do with myself reviewing energy performance at the facility 6 months in, I was reviewing the targets on the electricity and gas side. Obviously, from the electricity perspective, things were looking pretty good. But when I started looking at on the gas side of things, the natural gas alone exceeded the modeled total energy consumption for the facility. So it was about varying from upwards of 6 times over. I should clarify that this is within the bedding in period, so we do expect in this period some of the growing pains and the pain share gain share agreement doesn't kick in until year 3. And the facilities are expected to take some time to optimize, but I certainly didn't anticipate an additional $100,000 on gas utilization for that year, and obviously puts us in a bit of a precarious position given we take the risk on the utility bills during that time. When I looked outside of my own facility and started looking at some of the other P3 hospitals across the province, they're generally, again, the P3 process is building ostensibly energy efficient facilities, but generally across the province they were performing well below their potential when compared to the benchmark. Again, they may build highly efficient facilities, but it doesn't necessarily come to fruition through the operating term. Now, bloated energy consumption wasn't the only surprise once we got into operation. Building functionality challenges, for example, there was an area of the facility that didn't deliver the correct pressurization because of ambiguities in the relevant code, and we weren't really specific in the outputs as to what we really wanted, and the consortium weren't well enough coordinated to catch it. Variation pricing. Certainly the only constant in healthcare is change, and that change generally comes at a cost. In reviewing the primer, the output specification was really not clear enough. It really isn't clear enough on pricing. The temperature control, as I was doing my walk around in the facility, we have an incredible HVAC control system, but I tended to weather a litany of complaints from the admin staff about them being too cold. The output specification called for general temperature ranges, which were consistent, but again, the sedentary administrative staff in the space weren't going to be comfortable with the 22 degrees when they don't have to move for hours at a time. The facility operations FM staffing, this is a perennial debate, as the procurement agent doesn't want to specify staffing levels because it constrains the operations team ability to innovate. But we've had FM service providers submit staffing plans that have been, somewhere in the range of 25% of what we understand to be the appropriate levels of staffing, and we know it's going to be untenable, but there's really nothing in the model to really prevent that from happening. So if we go back to our diagram and the team structure, you can start to think about some of the challenges or some of the gaps in the model that leads to some of these challenges. The designer, is really primarily focused on ensuring a compliant design, and that design supports the functional goals of the building. The contractor is focused on minimizing cost and meeting the scheduled substantial completion date. They have the most significant capital outlay and don't get paid until substantial, and the penalties associated with missing that date are obviously highly punitive. Infrastructure Ontario's mantra is really on time and on budget, and while they act as the procurement agent for the entire concession, they are really just trying to get a hospital built. And with this model, a hospital that can be built cleanly, typically within a political cycle, which is really I think one of the big drivers for the utilization of this model. And generally, as I like to say, not many politicians got elected by operating a hospital well for 30 years. And the FM service provider is trying to drive construction quality and ensure facility supports the operational deliverables. But I think anybody who's been through the P3 process understands that the FM service codes are often sidelined through this process. Having the design team report into the contractor versus reporting into the facilities management provider creates a little bit of a disconnect between that design and how it supports. And in the end of the day, it ultimately goes down to those three as the rest of the parties disappear, and they're really, the FM service provider is left to picking up the pieces of any gaps in the model. So in summary, this model can deliver very high-performing, cost-effective buildings. But again, we need to continue to understand and develop models that are based on the principle that buildings aren't icons but vessels for a function, and that particularly in this model, the FM service provider is ultimately going to be responsible for the outputs, which is the delivery of the asset in support of the care that we're trying to deliver. And we need to work to evolve this model to be more effective, to get the FM service provider engaged earlier and performing a more central role to throughout the process. I think at that point, I'm going to turn it back to Ghazal, who's going to talk a little bit about an alternative model.
Thank you, John. It was great hearing about your experience with P3 model. Now I am going to talk to you about integrated project delivery, which is fairly new in Canada, but there have been projects that are delivered under this model. So I believe some of you may have heard about that before, or may have even worked on them on IPD projects, which would be great to also hear about your experience with that during Q&A. But for those of you that are less familiar with IPD model, I'm going to describe it briefly. Integrated project delivery, IPD, is an emerging collaborative method for project delivery in North America that has been designed to address the issue of fragmentation in the industry, which I described earlier in the presentation. Since its introduction to AEC industry, IPD has become the subject of great interest, and IPD is believed by many to have the potential to revolutionize the practices and project outcomes in this industry. And we know that especially in the U.S., particularly in the healthcare sector in the U.S., it is now very popular and it's being used very often. AIA California Council defines IPD as a contractual agreement between a minimum of the owner, designer, and builder, where risk and reward are shared, and stakeholder success is dependent on project success. There are many success stories about IPD. Organizations like American Institute of Architects, AIA California Council, and IPD Alliance here in Canada have published several case study reports indicating the success of IPD projects. There are also studies that have compared the performance of IPD projects with non-IPD projects across various metrics. One of the largest studies has been done by Asmer et al., which shows superior performance of IPD compared to conventional methods in 6 performance areas, which are quality, schedule, project changes, communication, environmental, and financial. So as part of my doctoral studies, I wanted to understand what has been the experience of industry professionals and stakeholders with IPD model and capture a comprehensive understanding of the perceived benefits and challenges in this model and what we face in throughout implementation of IPD. So I interviewed 39 industry actors from 3 key stakeholder groups: owners, contractors, and designers across the US and Canada. And the respondents were selected based on their history with both conventional and IPD projects so that they could provide a comparison of the two. And also here is some information about the experience of the participants in this study, that they in general participated in more than 24 IPD projects, being involved in complex institutional facilities and commercial buildings like healthcare facilities, academic buildings, civic facilities, offices, and laboratories. So one of the questions I asked them was that why do you think we should select IPD over more conventional models? And what sort of benefits you see in that, now that you have participated in some and you have also the experience of working on projects being delivered under conventional models. And in general, I received different reasons for their choice, for their decision. And these reasons for selecting IPD can be grouped in 2 categories. Some highlighted the benefits of IPD that are more related to project-oriented related aims that help them to achieve project-oriented aims, such as reducing uncertainty in project timeline and budget, maximizing project value, addressing project complexity, and mitigating project risk. And some also told me that the reasons behind that are more stakeholder-oriented. IPD is consistent with our organizational culture. We want to gain market advantage, and also it is suggested to us by our trusted advisors. The participants also identified the means that are facilitated by IPD, things like enhanced collaboration, informed decision-making, accelerated adoption of innovation. These are the means that were identified by them that help achieving those project-oriented and stakeholder-oriented aims. But also, I wanted to understand what are the challenges of implementing IPD. We know that IPD is a soft innovation introduced to an industry that has been historically very slow in innovation adoption, as I mentioned earlier in the presentation. The benefits and superior performance of IPD have been demonstrated in several studies, but little research has been done to understand what it really takes to do an IPD project in practice, and what are the most prevalent challenges in the process of IPD implementation. So I wanted to have some answers for these questions. The industry professionals across the US and Canada that I spoke to identified 28 different challenges in implementing IPD, which can be categorized in 7 larger categories, which are sustaining a collaborative environment, dealing with the operating environment, building the right team, embedding IPD concepts, making sound and timely decisions, changing actors' roles, and developing high-quality design. This red number, the percentages, show the percentage of the participants that highlighted those categories of challenges. And you see that 5 out of 7 of these larger categories of challenge that I described were mentioned by more than 90% of the participants. But not only I wanted to understand what are the challenges in IPD implementation, but also I wanted to know how are they, what are types of challenges that owners face versus contractors face versus designers face. So what are the differences between different stakeholder groups? Here is a visual that I developed, and here you can see the detailed results. I don't expect you to read this. You will have access to the slides, and you can have a look later. And I also published a peer-reviewed journal article on this study, and the link is at the bottom, so you can also have access to the article that describes all the results in more detail. But here I wanted you to get a grasp of what have been mentioned in the interviews in relation to the challenges of IPD implementation. As I mentioned, in total, 28 different challenges are identified, which are those smaller texts that you see around the circle. Which I grouped them in 7 categories, and that outer ring around the diagram shows those 7 categories. I calculated the rate of the respondents within each stakeholder group who pointed to each of the identified challenges and developed this diagram. The rate of the respondents that pointed to each of those challenges increases with distance from the owner. So the further the dot is from the center, it means that the larger group pointed to that specific challenge. Here I want to show you the differences between perceptions of different stakeholders. In this diagram, the blue color represents the owners. Here, the green represents the contractors, and the orange represents the designers. So this diagram shows that the level of concordance among stakeholder groups varies across different identified challenges. For example, as you can see, high level of concordance exists among 3 stakeholder groups with regard to the challenges faced in building the right team to be able to do an IPD project successfully. But less concordance exists in challenges about developing a high-quality design. You see that there are mainly designers that are concerned about the quality of the design that is being developed under IPD model. So here, these are some of the challenges that have been mentioned by those industry professionals that worked on IPD projects and were able to compare those with a conventional method. So we see that, of course, there are a lot of opportunities that IPD brings to projects, and there are benefits in that, and we heard about the success stories and even how IPD outperforms other conventional methods that are being used in delivery of building projects. But there are a bunch of challenges that are also being faced, and some of them have been consistent. So as part of my research, I don't show it here, this was just too much of material, but I also compare how these challenges have changed over time, whether there are some that were being faced, let's say, 10 years ago, 7 years ago, and now we don't see them anymore, or there are some that have been consistent, and we see that some of these larger challenges have been consistent through time. So we see that there is really a big concern about the structure of the industry and what types of changes we need to make sure we facilitate adoption of IPD to be able to take advantage of all the opportunities it introduces to the project, and although to have those success stories similar to the projects I described earlier. Now I'm going to pass it again to John. He will talk to us a little bit about use of IPD in Ontario, in public sector, and particularly for healthcare. Over to you, John.
Thanks, Gazelle. Am I still on the? Can people hear me? I'm assuming. There we go. I'll assume that I'm being heard. Somebody jump on if I'm not. So, yeah, I'll just touch on this briefly as we're coming close to time, and we want to leave a little bit of time for some questions. Obviously, across the sector, there's the application of the IPD model has been fairly limited thus far in healthcare. I think in Toronto, particularly, UHN has done a bunch of work to integrate that model over the years in some of their research facilities. Although they call it the ITA model, which is the integrated team approach, but obviously very similar. I think earlier in the earlier 2000s, the Mars Tower fit out, which was about an $80 million project, was implemented through that, and then at the Toronto Western facility, they implemented about a $140 million tower in research. And I think one of the reasons that it lends itself well to that is that there isn't necessarily funding through the Ministry of Health, and B, that the multiple stakeholders involved in research projects, both from a funding perspective and then from the multiple stakeholders involved, and also the deftness of the model to be able to accommodate changes in grant funding as it comes along. So I think in the case of the Krembil, I believe the project actually grew in budget, but also grew in funding over the course of the project. When we look at, obviously one of the sort of obstacles to implementation of this model has been that Infrastructure Ontario has, primarily been focused on their AFP DBFM model. I think that what's interesting is that they've recently actually applied a new model, the Alliance Contracting Model, which is in its essence, it's a form of P3 that delivers projects using the collaborative approach between the public sector and private sector parties, with the shared risk that it's essentially another label on an IPD project, and they're using that at Union Station. So that's kind of an exciting evolution in terms of looking at different ways to solve some of the challenges that we've experienced through the P3 DBFM model. I think that and as I look at a couple of the other projects, the project we implemented at Etobicoke, where we were attaching a new P3 to an existing facility, that project would have lent itself very well to the IPD process, given the number of changing operational challenges that came about through the project. And I hope that through our next phases that hopefully there'll be an appetite within the procurement agents and in the Ministry of Health to pursue this. But I think I want to stop there and open up the floor, because I'm sure based on Gazelle's rather in-depth presentation that there'll be lots of questions and engagement. So maybe over to the floor.
We'll now open the floor up for questions. First, I'll read the questions in the chat box. I don't see any there right now. But after that, anybody can unmute and ask questions, and you can unmute by either right-clicking on your phone number in the audio box to the middle left, or press *7 on your phone. I guess I have a question for you, John, and I just thought about in the P3 model, the FM service provider. How do they deal with the lack of resources, and could they get their critical inspections and preventive maintenance completed?
It's a really good question, and maybe the bigger question is, how do I, as an owner, deal with any shortfalls in the FM service provider's work with respect to critical life cycle and maintenance activities? Obviously, the model is really an integrated FM service delivery model, and I would say that in generally the industry is still growing into that model, that the downward pressure at the time of bid on the FM services generally leads to an under-resourced FM provider. And the project agreement has multiple means and methods to manage that scenario. But again, as an owner, you get into the position of potentially beating a dead horse. And what I mean by that is, obviously you have applying deductions to a service provider who's struggling financially can lead you down a path to generating more risk. There's a little bit of relationship management, but right now we're really working hard to educate the industry and have them make sure that their focuses are aligned with what we understand to be the needs to mitigate our risks.
All right. Andrew Wong has asked a question. Do you have any experience with renovation projects using P3 model?
I don't personally have any experience, although there are renovation. There were about 16,000 square feet of renovation work that went on as a part of the larger project at Etobicoke. So the answer would be yes. Was there a follow-up question with respect to the efficacy of that?
I'm not sure.
I'll assume. Yeah. I mean, I think the model is really designed around large capital projects. I know that there was a much more considerable renovation component to the P3 project at St. Mike's Hospital downtown Toronto, and I believe in that case they pursued it under a design build finance model due to the complexities of trying to integrate the M into that piece. So it has been applied, but really only I think as an appendage to other larger capital new builds.
So your builds, is there a standard you build to, like LEED Silver, LEED Gold, or other?
Yeah, there's certainly LEED Silver is mandated, I think, through all of Infrastructure Ontario's projects. All of the other building standards obviously apply, but we're not, like, for example, we haven't pursued a well building, although there has been talk about looking at potentially targeting a well building standard in one of our future projects.
All right. I got another question as well. I think about the incentive for the facility maintenance providers to do energy efficiency programs through the life cycle of the P3 program, and wondering how you've looked at that. Are they doing the Schedule 36, which really doesn't give you any incentive, or is there some other method that was in the contract to provide for energy efficiency projects after the building is built and operational?
Yeah, so for Peel opened in 2016, so we've actually we're just into the third year, or into the end of the third year. So we're currently modeling the pain share gain share for year one of the actual energy utilization where they're at risk for it. So I haven't got far enough down the road in the projects that reference Schedule 36. Brampton was actually unfortunately done based prior to Infrastructure Ontario and on the PFI model, and the triggers for benchmarking and for implementing the utility model weren't in the end relevant, and so there's been some challenges. In that case, it's really been a question of working with the service provider on where do the synergies, obviously they have life cycle dollars. We have an interest in further energy savings and further efficiencies for our building. So finding where we can align those projects with their life cycle replacement, potentially looking at the hospital itself, providing some additional capital through the variation process to have enhance an existing life cycle project that's on their side so that we can generate and capitalize on the energy savings on the other side of the contract. But the energy model does, the Schedule 36 ostensibly incentivizes them through the potential of gain share on their side. But I think to your point, I don't think I've really seen that come to fruition in any of the active models.
Yeah, that's what I was wondering. Brandon Campbell is asking, what can you speak to on the length of engagement for the contract if relations sour and individuals within the roles change over time?
Is that a question with respect to IPD models or with respect to P3?
He doesn't say, but maybe we can pop that in there.
Well, I can certainly speak to it from. So we have a 30-year contract. Oh yeah, so the DBFM. So we have a 30-year contract in these agreements. When we say relationships hours, I mean I'll flip that around and say, if the performance gets to the point where the service provider is failing to meet the key performance indicators in the terms of the contract, there are provisions in the contract to move towards either a complete default on the contract or a removal or replacement of that service provider. So generally, the relationship souring is usually tied to some significant underperformance, which there are provisions in the contract to have that underperformance translate into replacement of the service co, and that obviously provides leverage to the owner to incentivize change. I think to your second comment on the individuals involved, that's a challenge industry-wide. Obviously, the FM industry is a challenge in healthcare is a thin industry, and we have experienced high turnover. But again, we tend to measure it, based on the impact of those key personnel leaving on their operations, and then utilize the project agreement to do its work. If that answers.
All right, we have another question here from Andrew. Have you completed any renovation change to clinical models, medical equipment upgrades, and after handover to health authorities? How are these types of projects handled?
Okay.
I guess maybe if
you're talking about
MRI in.
Yeah. So yeah, we've actually completed. Any changes are post substantial are managed through the variation process. We've had kind of a little bit of a diversity of experience across the three projects. I think that we've been able through our original P3 with Brampton to be able to implement some fairly substantive renovations. The service provider there is Ellis Don, who also does a little bit of construction from time to time, and so they've been able to leverage their corporate resources, and with that respect, the service provider is sort of well positioned to deliver change. I think some of the challenges are with respect to some variation in pricing and some deviance in pricing and how they price these variations from service co to service co, and certainly in some of the newer ones where I think there's been more competitive downward pressure on their overall FM bid, that's driven much higher pricing on the variation side of things. So if Peel isn't old enough yet to have done anything terrifically substantial to it, but we have seen on some of the minor changes some rather high pricing, and ultimately the owner's recourse in that position is to essentially self-perform. And once we start self-performing within the context of a DBFM, now we're breaking apart the whole integrity of the risk transfer if I'm touching the electrical system and touching other facets of it. So that is actually an outcome that's not really something the owner or the service co and project co want to pursue. So we use that to try to leverage getting appropriate pricing. But that's sort of, if that's a long-winded answer to what may have been a shorter question.
I think it was quite well done. We're at the top of the hour, so I'd like to take the opportunity to thank Gazelle and John for taking the time to share with us some of their knowledge and experience with procurement practices. And also thank you to all who have participated in this webinar. Hopefully you have found the information helpful. And with that, we'll now sign off. Have a great day and a relaxing holiday season for everyone.
Thanks very much, everyone.